Okay, in this video, I'm going to continue to go over some of the Module 9 questions from WebWork. And this is on 9.3, number 53. And this are looking at the graphs of quadratics, which we know are parabolas. So this one says an object is shot into the air with an initial velocity or vertical speed of 640 feet per second. Its height as time passes can be modeled by the quadratic equation y equals negative 16 t squared plus 640 t, where t represents the number of seconds since the object's release and y represents the object's height in feet. So if you did graph this on Desmos, looking at the graph, you would start here. We know that that y-intercept, or in fact, well, we're going to call this the height, and here's time. We're going to have this parabola shape, and in real life, we're saying, it's why do I know that it's starting at the origin or it's starting on the ground? Well, that's because I have a plus 0. So when we think about our standard form of a quadratic, ax squared plus bx plus c, 0c is going to be our y-intercept. And it's also saying that it initially starts on the ground. And then we can use the formula, and we can even graph it on Desmos as well. So right here, this is saying after blank seconds, the object reaches a maximum height. So when we're talking about the maximum height, we're talking about the vertex. And the other reason why I know that this parabola is going to open downward is because we have the leading coefficient is negative. So let's go ahead and find the vertex then. So the vertex is going to be x equals negative b, and in this case b is 640, so negative 640 divided by 2a, so 2 times negative 16. So we have 640, oops, well, 16. So we have negative 6, I don't know why that's not writing now, 640 over negative 32. And so that means x is equal to 32 goes into 640. That's going to be, what is that, 20. Yes, so that's right. So that is 20 seconds. And then the maximum, if we plug 20 in, we would have y equals negative 16 times 20 squared plus 640 times 20. And so I can just use my calculator for that. So negative 16 times 20 squared plus 640 times 20. And that it does give us the maximum height. So we're using feet for feet and s for seconds. And so the object flew for, this is saying 40 seconds before it landed on the ground. In order to figure out when it landed on the ground, that would mean we would be using the height is 0. So if we set the height equal to 0, so for the next one, B, this one is A. For B, if we set the height equal to 0, we say 0 equals, actually they are using Y for the height instead of H. But then I can solve this, 640T, I can solve for T. And so since we're learning the quadratic formula, we can use the quadratic formula here. Later in Math 95, you will learn how to factor, and you could also solve this by factoring, which I would actually find for this one to be a little bit simpler. But something to also notice is everything here is divisible by 16. And so I could divide everything by a negative 16 to work with smaller numbers like I did in the last example. So I have 0 equals t squared, and then 640 divided by 16 is going to be negative 40t. And it just makes it so that your, oops, where did that go? Your numbers that you're using in the quadratic formula are a little bit simpler. So we're going to say t equals, and that's the same thing as x equals negative b, so that's 40 plus or minus the square root of 40, negative 40 squared, which will still be positive, minus 4 times a, which is 1, times c, which in this case is 0. So you'll notice that some of that is going to go away. I mean, you're not going, once you multiply by 0, that part's gone. And then we're going to divide by 2 times a, which is 2 times 1. So I have 40 plus or minus the square root. 40, negative 40 squared is 1600, because 4 times 4 is 16. And then we're going to put 2 zeros on the end, over 2 equals 40 plus or minus the square root of, or actually the square root, we already know the square root because I just squared that number. So that's 40 over 2. And that's where you're going to see the 0. So I have 40 minus 40 over 2, which is 0. And then I have 40 plus 40 over 2. 40 plus 40 over 2 is 80, which is where you get the 40 from. So that one is correct. Here, the object is going to land. It started out at 0. It lands at 40 seconds. And then the object was blank, how many feet in the air after 2 seconds after release. So if we go ahead and plug in 2, and I think that this is actually the right answer, but again, if we go ahead and put that on decimals, that would make it really easy, or you can just plug 2 in. So I have negative 16 times 2 times 2, which is 4, plus 640 times 4, and actually, wait a second. Oh no. Oh, I meant to put in 2. I squared it twice. So that's 2, and that's right. Okay, so the object was at 4,800 feet at 2 different times. So when we want to solve that, we would say 4,800 is equal to, that's the height, negative 16t squared plus 640t. So in order to solve this, again, I would want to use the quadratic formula. So I'm going to set that up. Let me go ahead and insert a page. So I have 4800 equals negative 16t squared plus 640t. So I'm going to subtract 4,800 from both sides. I get 0 equals negative 16t squared plus 640t minus 4,800. Oops. And just like I've been doing in some of these examples with the quadratic formula, I am going to want to, I prefer to use smaller numbers. I notice these are all divisible by 16. So I'm going to divide both sides by negative 16. And I get 0 equals t squared. What did we say that 640 divided by 16 was? 640 divided by 16 is 40. So I have minus 40t. And then 4,800 divided by 16 is 300. Is that right? Yeah. So I have plus 300. And then we'll go ahead, hi Kitty, we'll go ahead and use the quadratic formula now. So we have t equals negative 40 is 40 plus or minus the square root. 40 squared we already solved before is 1,600 minus 4 times a, which is 1, c, which is 300, all over 2 times 1. And like I said, if you do use the bigger numbers, you will get the same answers. It's just, you know, it's a lot more calculating. So 40 plus or minus the square root of 1600 minus 1200, because that's 4 times 3, over 2. And here we get 40 plus or minus the square root of 400 over 2. And the square root of 400 is 20. So our answers are going to be 40 plus or minus 20 over 2. And those two different solutions would be 60 over 2 if we add them. So that's 30. And then if we subtract them, it's 20 over 2, which is 10. So your two answers here should be, the object was at, this should be 10 seconds, and then later at, what did we say it was? 30 seconds. And so what you'll see is if you were to graph this on Desmos, and just like I did in one of the previous problems, I'm going to write y equals 4,800. That's going to draw a line here and here, and this should be 10, and this one should be 30 seconds. Okay, let's go on to the next problem. So I just have two more in this section. Graphing quadratic expressions, number 61. So this is 9.3. An object was launched upright at a height of 350 meters, and that's where you see that starting value in the equation, the 350 meters. Its height can be modeled by h equals negative 4.9. So again, I know that the parabola is opening downward because the leading coefficient is negative, and the y-intercept is going to be 350. So we're going to see this shape like this. Okay. And then where h stands for the object's height in meters and t stands for the time that's passed in seconds since its launch, the object's height will be 360 meters twice before it hits the ground. Find out how many seconds since the launch would the height be 360 meters. And so similarly to what I was saying, like here's 360. So at a certain point in time, it passes by both. At some point, it also gets to the vertex, that maximum. But it's going to go up and hit that point, and then come back down at a certain time and hit that height. So that's the 360 meters. And if you on Desmos were to type in this graph and then write y equals the 360, you'll get that horizontal line that will cross the parabola. Okay, so it will, the object's height will be at 360 meters twice before it hits the ground. Find out how many seconds since the launch will the object's height be 360 meters, and then round your answer to 2 decimal places if necessary. So what we're doing is we're taking that formula and we're going to set 360, just like you see here in the solution part that I copied, in for the height equals negative 4.9 t squared plus 60 t plus 350. And so to solve this, we'll always need to set our quadratic equal to 0. So we'll subtract 360 from both sides. And that leaves us with 0 equals negative 4.9 t squared plus 60t minus 10. And then we'll want to use the quadratic formula. So we have t equals negative 60. I can see that because I have a decimal value in here that I don't want to, I'm not going to want to factor or like divide anything out. So negative 60, because that's negative b. Remember our quadratic formula, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So that's where I'm getting that from. Plus or minus the square root 60 squared minus 4 times A, which is negative 4.9, times C, in this case, which is negative 10, all over 2 times negative 4.9. And then we'll want to continue to simplify. So I'm just rewriting the problem and doing one step at a time. 60 squared is 3,600. I might as well go ahead and multiply. I have 3 negatives here, so I will end up with a negative. 4 times 4.9 times 10. Oops. And I get 196 there, which is the same thing as 49 times 4, all over 2 times 4.9, which is 9.8. And so we'll keep going. We have negative 60 plus or minus the square root of 3600 minus the 169 is 3404 over 9.8. And then we're going to do 2 different solutions. So I have negative 60 plus the square root of 3404 over 9.8, and negative 60 minus the square root of 3404 over 9.8. Wait a second, that was negative 9.8. Okay, so on my calculator, I'm going to take the square root first of 3404. I'm going to add negative 60 to that. So I might as well just go minus 60. And then divide that by negative 9.8. So that would be my positive one, which is 0.168999. So typically we're rounding our answers to, it says round your answers to 2 decimal places. So we would call that 0.17 if we want to round to 2 decimal places. And the next one is the same exact process, but I'm going to have a negative square root of 3404, which gives me negative around 58, minus 60, and divide that by negative 9.8, and I get approximately 12, and they want 2 decimal places, so 12.08 should be that answer. So the object's height would be, and these are both positives, so we can think of in terms of seconds, 0.17 seconds it was at that height, and then again at 12.08 seconds. So the first time, and these would have to be positive values because you can never have negative time. And then 12.08, sorry, seconds. And they already have the seconds in there for you. Okay, one last problem on Module 9, and this one is problem number 63. Actually, it's very similar, isn't it, to the one we did in 9.2. So it says, currently an artist sells at least 220 paintings per year at a price of $60 per painting. Each time he raises the price per painting by $15, he sells 10 fewer paintings. So assume that he will raise the price per painting X times, and then that will give you 220 minus 10X, because that's the number right here. This is the number of paintings. And then each year for a price of 60 plus 15X. So we know that this is the price. The income can be modeled by the equation, and you would multiply the number of paintings, oops, this is the number of paintings, times the price to get the income, where I stands for the yearly income. If the artist wants to earn $15,750 per year from selling paintings, what should the new price be set at? So similarly here, we're going to set up this equation. Now, in order to get that ready to solve using the quadratic formula, we will need to FOIL that out and then set it equal to 0. So if we FOIL that out, we're going to have, and by the way, this would be a cool one to actually show in Desmos as well, but I'm wondering if I'll actually remember it. It's a lot of numbers to remember. So, all right, well, let's just go through and simplify this. So equals, I'm going to FOIL here. So we have 60 times 220 is 13,200, and there's no x's attached to that. And then minus 600x, 15 times 220 equals positive 330x. Oops, no. 3,300x, so that's the 15 times the 15x times the 220. And then we have 15x times negative 10x. So that's going to be minus 150x squared. Now to solve a quadratic, we always want to set it equal to 0. So I'm going to subtract the 15,750 from both sides and put it in descending order. So I have 0 equals negative 150 x squared. Combine the like terms in the middle. So that's 330 minus 600, or not 330, sorry, 3,300 minus 600 is a positive 2,700x. And then here we have the 13,200 minus 15,750. And that gives us negative 2,550. Now I can tell everything is definitely divisible by 10, and possibly everything could be divisible even by that leading coefficient, the negative 150. If it's all evenly divisible, then that just is going to make my numbers smaller to work with. So let me just actually see. Yes, 2,700 divided by 150. Okay, so if I divide everything by negative 150, can you hear my cat growling? Oh, kitty, 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 kitty. Equals x squared, and then this turned out to be negative 18x, and this turned out to be a positive 17. So again, I mean, of course you can use the bigger numbers, but like I said, you will get the same answers in the end. So, and it turns out like this is something that you're going to find out in Math 95. You can go through and do the quadratic formula. Sure, no problem. I can go ahead and demonstrate that. I have shown it a few times, but I happen to know that this one is going to be factorable. So some of you might be familiar with factoring, and here it would be negative 17 and negative 1. That those numbers multiply together to give you positive 17 and add together to give you a negative 18, which means that x will equal 17 and 1. If you did the quadratic formula with these numbers or these numbers, you should in the end get x equals 17 and 1. But remember, what they're going to ask for is the price. So if we go back to the price being $60 plus 15x, this is the equation for the price. So then if I go ahead and say, well, if I do one price increase, then I'm going to add $15 to the 60. So the lowest price is going to be $75. And then if I increase the price 17 times, I'm going to have 17 increases. I should do it the other way, just so for understanding. I would have 17 price increases of $15. So I'd have 15 times 17. I would have 60 plus 255 and that's going to give me $3.15. So that would be the highest price. And like I said, if you want to go ahead and play around with that in Desmos, you should be able to see those being the number of increases. And then if we go back and use the formula to find the new price. So hopefully, I know that was very long-winded and that was a lot of work, but hopefully those sort of answered some questions that you had about Desmos, or sorry, WebWork. And just let me know if you have any others you'd like to go over. Trying to find my stop button now. I want it to appear.